This conference will now be recorded.
So now, shall we continue? So how good you are with the case classes? I mean, you are good with case classes. You know all the different use cases we have discussed. But my question is about pattern matching. How it is for you? Are you fine? Are comfortable? Is it clear what I have explained yesterday? Or do you feel like there is a gap for you? So what's your feedback? I didn't get any answer. Should I take it as yes or should I take it as no? You are comfortable. You are not. Okay. What about others? Yeah. So what's time now? All of you are comfortable, right? Yeah, fine, no issues. See, before going to the inheritance topic, might be because yesterday Bharat was asking me a question, still he is not there. No problem. So might be I thought I would have started with this example. Later I realized I should have started from this and I would have given you with multiple objects with different case classes and different case objects, and I would have introduced one method that would have definitely made you comfortable. That would have given more clarity, much more understanding. Because as I started with this, my thought yesterday is to go with this and explain this to show you this. It's more like an option topic. What I thought is, as we have already discussed in option, I thought we are doing a similar topic to this one. So that's why I started from here and introduced all this, and I tried to make it clear for you. But later on, with the discussion what we had, I thought we would have introduced this example first. This would have given a quick understanding. Okay, we can have multiple objects like this, and we can do pattern matching like this. So that would be more easy for you. Suppose if we have two objects, what is that we should do? If you have three objects, what is that we should do? Yesterday, anyhow, I have shown you that three objects as well, right? Correct. What if you have, if you want to do the pattern matching with every object, we need to take a separate match case, separate, what is that case here, match cases. And then with that, we have to do. Now you see here, one quick example, just to get a quick idea. Definitely, Bharat, you can also see this because I only, made this example to give some simple and easy understanding to this case class, because I see yesterday, not you know about case class. I'm not talking about case class with this pattern matching. I didn't take multiple objects here. I just took only one object with two parameters. One case class with two parameters. If you look at this example, yesterday I have declared parameters here. Might be I shouldn't have used parameters. I should have used values like this. That would have given better clarity to all of you. But still, I thought we have to start at the more better level. Okay, we should have gone one level down and we would have started. Then it would have made more simple to you. But there is nothing wrong time to learn a topic. Okay, we can again have a quick understanding here. I don't take much time today, but just to make it easy for you and just to make simple for you, I'm explaining this. Okay, so what's happening here? If you look at it, if you look at this here, I have just one case class and I created multiple objects with values here. The only difference between yesterday's program and today's program is yesterday I used to pass parameters, alphabets here, variables. I have passed variables. We can also compare this case objects directly with the values like this. Now, if you see here, I created how many objects for this case class? I have created 4 objects. Now, if you see here, for default, we can use underscore. All of you know that we have discussed all these topics and we have implemented. Now you can start matching this. Suppose you start with C1. If you see here, if you start with C1 or C4, anything is fine, no issues. Now, in this switch case or in this case, match case. What we are doing here, we are trying to compare, we are trying to implement pattern matching here. I have 3 different patterns of case classes, one with 1 2, one with 4 6, one with 8. Now if you see here, we are comparing C1 with these patterns. Now what's happening? Does 1 2 exist here, right? Is this existing or not? So means this C1 is matching with this gets executed. And suppose if you pass C2, C2 is this one, which one? Second object. C2 is second object. Then that will be matched with the second case. Suppose if I pass C3, this is going to be matched with third case. The third case here directly. Suppose if I match for C4, then this is going to be, is there any match for C4 here? I don't have any match, then this default case gets executed. We get invalid object. You got this right? Do you get this example? I didn't do anything. This is not something really a tough example or a bigger example, and we don't have any dependencies here. We don't have any inheritance or we don't have any traits here. This is a straightforward example with just a case class here, and I created multiple objects, and we are trying to implement pattern matching with these objects. And what happens here, whichever the case is matching, that gets executed. As I cannot directly extract this variables, because if I want to get this 1 and 2, what I am doing, I can get 1 from C1.a. C1.a means A represent 1 and B represents 2 here. This B, 1 is passed to A, 2 is passed to B. So to extract that 1 and 2, I am just saying C1.a and C1.b to print it. When I run it, we get output like this. This time we get invalid, what is that, object. Suppose if I pass C1 here, I get 1 2. To extract the data, I am just applying C1.a and C1.b here. If they were variables, we can directly, what we can do? We can directly print those variables A plus B. As they were not variables, they were just only constants. So I am trying to get the actual value from the case class object, saying that like this with reference, I am trying to extract those actual values C1.a, C1.b, which is nothing but 1 and 2. All of us know that. Correct? So this is a simple example of understanding pattern matching with case classes. Now what we are doing here, this case class object is helping us to, we are having multiple objects here, and here what it is doing, it is helping us to implement a pattern matching here, so that we do the comparison and we try to get whatever object is matching here on that object. We perform some data analysis, we do some data processing. You get this right? But is this fine? I think we have took this back a little one level down now. So is it comfortable with this example?
Got it, Manohar. Yesterday only it's fine. I got that point clear.
Okay, actually, yeah, if you are clear, that I am very happy, because
yeah,
I thought
it's clear for me.
Yeah. So I brought this again to make sure that this is one level down to the yesterday's session, whatever we have discussed, so that it will be more clear for all of you. We can also take like this. Okay, is that fine for all of you now? You can also test like this, not with just variables, but also if you want, you can have direct values here. We can pass a static value, and also we can compare it. That's also possible. Got it right? This is also another scenario. You can make a note of it. So might be I'm just copying and pasting it just for your convenience, so that next time we can start from there with this example, and I can come to this, so that it acts as a roadmap for me also. So sometimes, okay, for you also, I'm just pasting in your chat box. If you want, you can copy this example if you think that that will be helpful for you. Now I am moving to the next topic today, inheritance. I want to jump to inheritance because many of you are waiting for next topic, because we were traveling with case class for many days. But probably you might, if I continue this, you get dreams of case classes. So I don't want to have that burden to you. So what I will do is I will switch to inheritance, right? So now, so inheritance, what is this? See, this is a simple and very very simple and easy topic here, and also one of the most used topic in our projects. Probably in most of the cases, without inheritance, I don't think probably a project exists, except when you develop standalone applications. Otherwise, if you go to any project which is a standard project, I am not saying about just for standalone applications that we can prepare without inheritance with just functional programming. But when we go to any big project where it has a lot of object involved there, definitely inheritance will be there. So what is inheritance? Okay, it is a simple thing in deriving properties of parent to a child class, and that's what we call inheritance is. What is inheritance? Deriving properties of parent to child. Do you understand this, folks? Or we can also say parent or superclass or base class. You can add whatever the terminologies you want. To here, it can be parent or child or subclass or okay, or derived. We can also say derived class. That's what inheritance anyhow. What is the advantage of inheritance? You can see here. It gives us a reusability of code. What is that? We can say reusability, or we can say something here. Inheritance avoids. This is very important point. Instead of saying reusability of code, I don't think this is a valid point here. Maybe I can add like this. Inheritance avoids data redundancy. What it avoids? Data redundancy. For some of you who had attended Python, again this will be a repetitive picture for you, movie for you. If you feel bored, just you carry out with your other things. Otherwise, you can concentrate. It avoids data redundancy. See, if you want to avoid, if you want to have code reusability or code redundancy, if you want to avoid code redundancy, one-stop solution for that is methods, sir. Methods are very useful to avoid repetition of code. So, there is a frequent question. Sometimes in interview, people ask this question. What is that? How do you avoid code redundancy? How do you avoid data redundancy? The question seems to be same, but there is a bit of difference here. When somebody asks this question, definitely there is a thought process to be involved into this. We have to give some thought process. See, usually inheritance is introduced to handle data redundancy. Of course, code redundancy is already handled by these methods. We are handling it with methods. What is that? Methods avoids what? Code repetition or code redundancy. Also, methods provides reusability. Correct or not? So this is one thing you have to keep in mind. If you want to have avoid code repetition, if you want to avoid code redundancy means repetition, sir. You don't need to think this is high vocabulary word here, just a repetition here. If you have code repetition, we can handle it with methods. But if it is data redundancy, this is a challenging issue. We cannot avoid data redundancy with methods, sir. It's not possible, but we can avoid it with inheritance. So you have to be clear in these two aspects. So what avoids what means? Probably in general discussion, people say that inheritance avoids code redundancy. To be specific, it's not code redundancy, it's data redundancy. Might be the interviewer might ask a question, then why do we use methods? Already we have methods inside that any class. Then how this inheritance avoids code redundancy? Then we will scratch our head. So make sure you are clear with the terminologies here. Make sure you are clear with what is doing what here. That is important. Now question is, already we know about methods. Already you know how methods avoids code redundancy, code repetition. Now I am going to talk about this data redundancy, how it avoids. Suppose you take an example. You have 3 different classes. I'm taking some birds as examples. I'm taking a paint here because paint is good to have for us. I have three beautiful birds, three beautiful flowers. What is that? One is a flower name. One is a rose. Okay, second flower, you can take it as a lily. The third one, you can take it as a another of your choice, anything. Then here, rose, lily, and then that. See, I am not able to get even flower names. Can anybody tell me one more flower? Jasmine. Thank you. Okay, jasmine. There are so many flowers. Now you see, for any of these flowers, so what do we need? It will have a name, flower price, and also you can add location where these flowers are grown, like in Hyderabad or Delhi, Bombay, somewhere. Tulips usually they will grow somewhere near Bangalore, like that. Now so many flowers were there. So usually every flower has, all these are belonging to a category called flowers, and rose is one among them. Lily is belonging to a class called flowers, but class in sense that entity. Okay, like we belong to all humans belong to a class called all male and female will belong to a class called human. That is one class. All animals, you see lion, tiger, or whatever animal, they belong to a class called animal. That's what I am saying here. So even though all this belongs to they are flowers, now individually every flower has some attributes. What is that? Every flower has some attributes. Even lily has some attributes, but most of these attributes are same. Flower attributes, not the values. I am saying about the attributes here, are the properties. What is that? Rose has name, and rose has a price. Rose has a location, or you can give it as size also. Flower size, small or big, whatever you want. Lily has a name. Okay, even lily has name, some names, small lily, big lily, like that. So this has some price, this has some location. I mean, jasmines means what type of jasmine? There are different categories among them as well. Flowers also has categories. Suppose jasmine has name, jasmine has price, jasmine has location. Means if you see, when they are independent, for each class we declare 3 attributes, and for all together all 3 classes we are declaring how many attributes here? We are declaring 9 properties or 9 variables. But if you give a clean look at it, if you look little deeper into this, you can see almost all the properties of all these 3 different flowers are same here. And all they are belonging to a same category called flowers. Now we can avoid this repetition of attributes here, repetition of data, redundancy of data. And how do you avoid it? By using this inheritance. Now we can do one thing, instead of declaring 9 variables, because all these properties are same for all the different flowers here, individual flowers, as the attributes are same, we can do one thing, and they are belonging to a category called flowers. We can do one thing now. Whichever is common for all these classes, we move all this to a common class. We take one common class here. We take some common class here. In that common class, we move all these common properties of these classes, rose, lily, and jasmine, into this common class, which is at the top of this classes. We call it as a parent class. Now this parent class will have all the common properties of its subclasses. Now if you see, you get a quick idea like how inheritance is going to help us. Now this is my parent. As I don't have sufficient space, I made it little smaller. And this parent class name is flower. What is that, gentlemen? This flower. Flower means it can be, that flower can be a rose, If flower in sorry, if otherwise I will directly take like this. So now rose is a flower. Now if rose is inheriting from flower means what? Rose is a flower. Now lily is a flower. Jasmine is a flower. Got it right? So means what are the subclasses? Here the bottom level classes we call them as subclasses now. Now what did we do now? As we found that there is a repetition of data here, variables, and there is a redundancy. That's what redundancy. And these are almost common for all the classes. What we have done is we took one common class for all these classes and we named it as a parent or a superclass and moved all the common properties to this parent class or superclass. Now this rows, what is it? Sorry, this name, this price, this what is that? Location. Now all those properties are declared with parent itself. Now we don't need to declare again these properties with the child classes, sir. It's not necessary to have these properties with the child, sir. Not necessary. And here also we don't need them, sir. Here also we don't need them, sir. We don't need all this here, sir. Now what's happening? With just 3 variables, I am able to finish my variable declaration. Now what's happening? I am avoiding this data redundancy here. I moved all the common properties to the parent. If at all, if I want to declare, I will declare that specific flower entities here. If rose is there, that row specific variables will be declared and common properties are there in the parent, and lily specific properties are declared and jasmine specific properties are declared here. Only specific property to child class are declared in the childs and all the common properties are there in the parent. So what is the advantage here? As you say, it is avoiding lot of data redundancy. Of course you can have methods also inside that and you can avoid to some extent if any common code implementation is there for all these classes, that common code, that common methods you can put it in the parent class. In that way we get a lot of advantage here in 2 ways. One, we can avoid data redundancy. 2, we can also avoid code redundancy. With methods we avoid that code redundancy, and with variables, with these variables we avoid data redundancy. Data means variables, sir. Got it right? So now what's happening here? This is idea about a simple quick idea about the inheritance thing. So what inheritance is doing here? Whichever property is common for childs and we are moving it to a parent here. Whichever properties are specific to the childs, we declare them in the child classes itself. And once you inherit a class from a parent, then all the properties of parent are inherited in subclass except private properties. Got it right? Private properties are not inherited, sir. And it is very rare that we declare private properties in a parent class. Most of the properties are protected or public, but not private. You got the point, right? This is simple idea and quick idea about inheritance. What is that we are getting with inheritance now? It avoids data redundancy, it avoids code redundancy. It will do both. It does both here. Now, what is the other things here? We declare all common properties. What is that? We declare all common properties of subclasses, where in a common class called as what is that called? Class called as parent or superclass, or you could call it as base class also. That is one thing. Second thing, a subclass inherits a superclass. A subclass inherits a superclass. How it inherits? By using the keyword extends here. If you see here, what is that keyword we use? Extends. So inherit superclass using keyword. What is that keyword, sir? Extends. That is one more important. Next one. Other important thing is see the bottom level classes. Whenever we declare classes at the bottom level, they are subclasses. At the top level classes are parent or superclasses. Got it right? Classes at the bottom are subclasses. Classes at the top level are superclasses. You can also have a point of this. Okay. classes at the bottom level. What do we call them, sir? Are subclasses, and at top level are called, what do you call them, sir? Superclasses. Did you get this, sir? So now, finally, this is idea about the inheritance. You got it, right? How inheritance is useful to us. This explanation definitely gives you a clarity on this. So are you good with this discussion, with this introduction to inheritance? Are you clear here? If you are clear, then we'll just move to the types of inheritance. From there, it doesn't take much time, sir. We can probably finish inheritance, sir, probably today or tomorrow. We don't need much sessions for inheritance. Sir. Okay. Now, types of inheritance. When you talk about types of inheritance here, okay, we have actually 5 types, but the Scala supports only how many types, sir? It will support 3 types. It doesn't support multiple inheritance, and even hybrid inheritance involves multiple inheritance in many cases. So it by default it supports 3 types of inheritance. What is that? Single inheritance, multi-level, and then hierarchical. These are the supported inheritance. And multiple inheritance is there here as well, but the point is it is not directly supported. It is implemented with thing called traits here. Okay, multiple inheritance. Okay, not supported with classes, but still we will check it, sir. Not an issue. Not supported with classes. But how can we implement it? We don't need to feel worried here. We implement this multiple inheritance with the traits, sir. We can do it with traits. There is nothing to worry about it. Okay, and even hybrid. Hybrid, we can mix any 2 inheritances, that becomes hybrid. But actually, the perfect way of implementing hybrid is either usually it will have a multiple inheritance involved into that in most of the cases. That's why if you don't use multiple inheritance, then you can make hybrid even with these 3 classes. Got it, right? So hybrid you may implement it, not an issue. Might support because it's a combination of any 2 inheritances. No need to worry about it. So now what is single inheritance? You just see the syntax here, sir. Single means one parent, one child. Single inheritance means, sir, what is it, sir? Deriving one subclass from one parent class. One subclass from one parent. This is our old China concept. You know, right? Every parent can have only one child in China. 4 or 5 years back. Now they made it 2, I hope. So this is single inheritance, deriving one subclass from one parent or one superclass. You can name as you like. That's not something to be worried. And here, how do you declare it? It's a simple thing. You need to have the syntax look like this. Already we have syntax here. First, you should have a parent, because without parent, you don't expect child, right? You have a superclass, or you can say parent, or you can say, what is that? You can also say base class. First, you prepare your superclass. Then you can see here, declare a subclass, and you apply extends keyword between the subclass and superclass. That will give inheritance between these 2. That will provide inheritance between superclass and subclass. It's like, you know, what is that? It's like a DNA for a class here. You know, how can we say a child is belonging to some parent? DNA test is the best test. Here, extends is something which is used to inherit this superclass to subclass. You understand this, sir? So that's idea about this. This is single inheritance, one parent, one child. You do one thing, sir. This is not a tough thing. I'll give some requirement, implement it quickly. Object is as usual, sir. Object is as usual. You don't need to, you're not going to have something else. You just create one more important thing in inheritance, create object for subclass. It is sufficient if you create object for subclass. No need to create object for superclass, because superclass has all the common properties. Anyhow, subclass will inherit that. Then if you create object for subclass, automatically you can access or you can invoke the properties of subclass and the properties of superclass with the subclass object. Got it, right? If somebody marries Mukesh Ambani's son, automatically she is a owner of his that son's property as well as Mukesh property. Same thing here, right? So now we'll take an example, sir. I'll give a small requirement. Take simple classes. I am not giving too difficult examples here. Very simple and straightforward to quickly understand inheritance and its importance. That's all. Take a class A, take two variables A, B, set data for them. It's up to you whether if you use constructor or you are going to use method. I prefer to use method for now for some time. Okay, take this set data and get data, two methods. One method to set values and one method to get values. Take a subclass B, extends A. In this declare one instance variable C, like how you have declared two instance variables in A class. In B class, declared one instance variable C, and then just do the sum of two numbers. Sum of two numbers. But extend A from B from A. And while doing sum, you have to use the variables of A class, not the B class. This is just only to assign results. So what I want is you find the sum of two numbers by using these variables from A class. And also one more thing, when you create object for B, B can have access to methods of all the members of A class as well as a method of itself, members of itself, except private properties. If private properties are there in A class, then they are not accessible, sir. Otherwise, all other properties are accessible to B. And even in B class, if you declare something inside that private, then right, can we access private properties directly outside? Not possible. Only through public methods we can access them. We had discussed this. So this is the requirement, sir. So why don't you test this code now for single inheritance? Implement this code. Okay, take 2 minutes and implement for single inheritance. I don't have too much in this topic. This is the concept. Mostly this is the concept. And I just only give you the difference between single, multi-level and hierarchical, and also explain what is the problem with multiple inheritance. And I just give the requirement, you keep implementing the program. That's all. So do it now, sir. Just take 2 minutes and finish it. Then we will switch to the multi-level, then hierarchical. If possible, we'll finish all the three today itself. It depends on your speed of coding. So is it done, sir? Okay, if anybody confirms, then I will implement it and finish this single inheritance. Okay, sir. Let's take an example. Shall I go for implementation or shall I wait, sir? Can anybody confirm? I think you are busy writing coding, seems like.
It's 10 Manohar. You can go ahead.
1 minute, no problem. Somebody wants me. Okay, no issue. Okay, let me write the code here. Something like take a class here, class A. I told you to declare two instance variables, var a colon int 20. So you don't need to initialize, of course. Just take it as 0 and 0. Then take a method with it doesn't return any value here this time. Return type is unit. Okay, similarly, one more method. You get error because already class A is there. So I put it as A1, no issues. Then one more, get data. Then this can be unit, just I'm printing it, I'm not doing anything, I'm not returning values. So I'm just printing it. Here, just initializing the data, A equal to 10, B equal to 20. You can do parameter passing if you wish, because we know all that stuff. Println A, then println B. Just printing the values. I'm taking one subclass, that is class B1 extension A1. This is what happens with inheritance. Even this is same in Java as well. Not just this is specific to Scala. Even in Java, we follow the same keyword, same thing. Now, declare one variable var c colon int equal to 0. And then take one method sum. Okay, it's a default method, no need of any parameterized. If you want, you can return data, or you can print your value inside method itself. Okay. So now what I do is simply SSC equal to A plus B. I don't do anything. Just printing inside the method itself. So this is a simple concept. Now, if you look at this program, here in the subclass, I'm trying to find some. And this A and B, I didn't declare them in the B class, but I'm directly using in the B, but actually they were declared in the A class. And I'm able to call this A and B here because we have inheritance here. That allows you to have access to all the properties of parent or superclass. Okay, and these are all public members, no problem. We can put protected as well here. So that's what happened here. This is possible. Why? I am able to use this AB here, and this is possible because of inheritance. Got it right? Now, what do you do right now? Go to this singleton object, create an object for B class where B equal to new B1, sorry. Okay. Now what do? First you call the methods set data, then if you want, this is optional. If you don't call set get data, nothing happens. B dot Got it, right? You can see something here. Do we declare this set data and get data in the B1 class? No, I didn't do that. But I am able to access them here on B reference. This is possible because B is a subclass of A class. Okay, otherwise we cannot call methods of one class on reference of another class. Do you think it's possible? Not possible. And now finally I'm getting some here, which is a method of B itself. Okay. Now what do? Just run the program. You should get output as 10, 20, and 30 without any errors or without any exceptions. We are able to run this program successfully. So this is simple idea of single inheritance. Multi-level means, I told you, right? If you just know one type of inheritance, this is almost same for all types. Okay. Only few differences are there here. Second one's multi-level inheritance. Okay. What is a multi-level inheritance? What is it, sir? Something like that. No, it's not two parents. We inherit a subclass from a superclass. And from that subclass, again, we inherit one more subclass. And from that, one more subclass. Okay. Like this. This continues. This is multi-level. Two parents, one child is a single, it's multiple inheritance. But in multi-level, what happens, sir? We inherit a subclass from a parent. We know that is single inheritance. And again, from that subclass, we inherit one more subclass. Means extending single inheritance gives us multi-level. Got it, right? The concept is same. Now the properties of A are inherited to B. And the properties of B are inherited to C. Okay, and the properties of C are inherited to D. See, inheritance is a bottom-up approach. Somebody is asking me a question. Usually what happens in inheritance is we inherit properties of parent to child, and we access properties of parent or child through child class object. And reverse is not possible. If you create object for parent, you cannot access properties of child. It's not possible, sir. Got it, right? Bottom up means, what do you mean by bottom up is the bottom level classes have access to top level classes. That is the meaning of bottom up. Okay, and vice versa is not possible. Top bottom is not there. Got it, right? That is not there with inheritance. So point clear, right? Here we cannot access the members of B class through A class object. Of course, reference is different. Okay, there is a concept of what is that loose coupling, which I have explained yesterday. When we come to that topic, I will give clarity. If I again introduce that now, again it is a confusing for everyone. I don't want to do that now. Let me finish inheritance first. So one thing in multi-level inheritance is a bottom level class has access to all top level classes. What is it, sir? A bottom level class has access to all top level classes. Do you get my point, sir? So that's the point. Now what do we do right now? And if you create object for the bottom level class D, it is enough. D can have access to C, B, and A. And if you ask me, can't I create object for C, B, A? You can create. If you wish, you can create, sir. If it is necessary, you can create. Otherwise, we don't need. Got it, right? Now, what do you do right now? Take a small requirement for this. Continue the same previous requirement. Take A class and B class as is. You don't need to change it, sir. But add one more level to this requirement. Take C here, another class C, and take one instance variable D. Variable names are your choice, sir. Method names are your choice, but just implement this scenario. That is enough for me. And this you can take some mul here. In this mul method, you do the mul of multiplication of what product of AB from A class and C from B class, just to prove that the C class has access to properties of all its parents. Got it right? So do the multiplication by using the properties of AB from A class and C from B class, and just create object for C class, instantiate C, and try to call all the methods. Usually you should call set data if you should use AB here. Okay, if you should use AB, you should call set data. If we should use C, we should call sum. Without calling any one of these two methods, it won't work. You get error. Keep that in mind. Is this fine for all of you, sir? So implement it, take 2 minutes and implement this program. This is just a simple extension to the previous single inheritance. Hi, team. So let me implement this program. Hope you are done with this multi-level inheritance. There are so many things. See, programming is like, all of you know, sir, you are working people. It's like an ocean. If you touch one topic, that topic has so much. We can discuss that for at least 1 week or 2 weeks. That's how programming is. Now I am extending this, adding one more class to this, sir. What I'm doing here is I'm taking class C1. Extends what, sir? B1. It's not like you should take one for everything, sir. I just took it as a, like, kind of a standard like that. It's all. But it's not necessary. Where d colon int equal to 0 and then def. I need multiplication, sir. And then I'm printing in the method itself. For now, I'm not returning. We know all the standards, how to implement code. Usually, when you do some business logic in a method, we should return that result, sir. That is very important. But here, as we are just testing multi-level inheritance, I am printing in the method itself. But the good practice is returning the value from the method. And we know, anyhow, we have done that. That is not something difficult for us. Okay. Where spacer. D equal to A into B into C. Okay. Simply say println of B here. And it's giving me some error. Why error? Should declare some data type. Of course, it will automatically take the data type. Sorry, here you don't need it. Also, the error is because of this var. It's a mistake, sir. Once you declare a variable, you don't need to declare it. And also, the error is with the println method. Okay. These are the two mistakes I have done here. Declaring the variable again in the method as var. Okay. And second thing is there is a mistake with println. Anyhow, should be a local, right? You take it like this, it should work, right? Yeah, it has to work. There is some mistake here. Even you can declare like this, sir, it becomes local. It's not like if you declare it as instance, it doesn't mean that you should not declare that variable here. The scopes are different. If you declare outside method inside class, it becomes instance. If you declare inside class, it becomes a, what is it? Local. Got it right? So what I'm doing is, anyhow, I don't need that right now. So what do you do right now? So we are done with this. So we take C class, we had implemented null method and implemented the product and printed that there itself. And now create what object for which class, sir? B class or C class? Create for object for C, C1. Then what is that? C dot set data, C dot get data, C dot sum, and finally what is that? C dot is it fine, sir? Now you see here, the C class is able to access AB properties of A class and C property of B class. Why? Because this is multi-level inheritance. The bottom level class, the bottommost class has access to all top level classes. It's like real inheritance. Okay. Now create object for C alone. If you want, you can create object for B and A. It's up to you, sir. If you want, you can take it like that. You want to test it. Finally, call the methods from set data and sum. Get data is optional. You don't call, nothing happens. Only thing is you don't see that basic inputs A and B. That's all. Now run this code. Now you can see 10, 20 are from A class and 30 is from B class and 6000 is from C class. This is multi-level inheritance. Okay, sir. Tomorrow I will close hierarchical. We'll finish inheritance tomorrow, sir. And again in the next class we will switch to polymorphism. Okay. Hope I don't see any difficulty here. The concept is simple. All of you are good, sir? Is it fine for all of you, sir? Okay. Then we'll take a break today. Again, I have another session at 11 o'clock. So we'll stop here, sir. Thank you. Yes, Harish, we have that. If you want, we will discuss. Let me finish polymorphism. Once we finish polymorphism, then I will explain is a relation and has a relation as well. Okay.
Okay. Thank you.
Okay.